In this video, we're going to discuss graphing quadratic functions that are written in this form right here. So a quadratic function has an x squared term as its highest power term. And so the graph will be, the shape of the graph will be a parabola. So the parabola will open up like this if a is greater than 0, and it will open down if a is less than 0. It won't open sideways because that would not be a function. That would fail the vertical line test. Now the point kind of at the top or bottom of the parabola is called the vertex. So we're going to want to be able to find that in order to graph the function. So if we have our quadratic function in this form, then the x-coordinate of the vertex is given by negative b over 2a. Now parabolas have symmetry, so that vertex is kind of on that line of symmetry. The right half and the left half are mirror images of each other over this line. So it's a vertical line that goes through the vertex. So whatever the x-coordinate is at the vertex also tells you what the equation of that line looks like. That line's called the axis of symmetry. So suppose that our vertex was at 3, 1 here. Okay, so x value of 3, y value of 1. Then, since this line goes through the vertex, it has the same x value. All the points on that line have that same x value as the vertex. So the equation of the line would be x equals 3. So let's practice graphing some quadratic functions. So here we have f of x equals negative 3x squared plus 6x minus 1. So we'll need to find the vertex first. So the x-coordinate of the vertex is going to be negative b over 2a, and in this case b is 6 and a is negative 3. So b is the coefficient on the x term and a is the coefficient on the x squared term. So in this case we get 1, so our axis of symmetry is the line x equals 1, and our vertex has an x-coordinate of 1. Now to find the y-coordinate of the vertex, we can just substitute 1 for x into the function. And so we get 2. So our vertex is at 1, 2. Let's plot that on our graph first. So there's our vertex. This parabola is going to open down because that value of a is negative. So we need to find 2 other points on the parabola to be able to graph each half of it accurately. So you can always substitute 0 for x and get the y-intercept because the parabola will always intersect the y-axis. So if we find f of 0, that's negative 1. So the y-intercept is at 0, negative 1, so we can plot that point. And then if we kind of visualize our axis of symmetry here, we know that the parabola is symmetric about that line, And so if we reflect that y-intercept over the axis of symmetry, we know that we also have a point at 2, -1. And so now we can draw in the rest of the parabola. I'm having a hard time drawing on this, but it should be a parabola shape, not a pointed V like mine looks like on the left half. All right, let's walk through one more example of that. So here we have f of x equals 2x squared plus 10x minus 3. Okay, so we want to find our vertex. The x-coordinate will be given by this. So this time b is 10 and a is positive 2. So since the a value is positive, this time the parabola will open up. And so the x value is -2.5. So our axis of symmetry is the line x equals -2.5. And the vertex has an x-coordinate of -2.5. If we substitute that into the function, we can find the y value of the vertex, which is important, so we can plot it on our graph. So if you substitute -2.5 for x here, you get -15.5. So our vertex is at -2.5, -15.5. So let's plot our vertex for starters. Alright, so our vertex we said is at -2.5, -15.5. And then we can find the y-intercept by substituting 0 for x into the function. So f of 0 is -3, so our y-intercept here is at 0, -3. And then we can use symmetry to get the other point. So the symmetry might be a little bit harder to visualize this time since our axis of symmetry equation is not an integer, but that's okay. So we have x equals -2.5. Just need to think about the fact that from the vertex to the y-intercept, just in the left-right direction, in the x direction, we're going from an x value of -2.5 to an x value of 0. So that's a distance of 2.5. So if we now go 2.5 units to the left of our axis of symmetry, we'll be at an x value of -5. So this point will be at -5, -3. And then we can draw in the rest of the parabola.